Hello everyone, welcome to my channel Physics Tricks. So in this video I'll be giving 8 formulas, right? And with that formulas I'll just give one trick that how to remember the formulas, right? So always remember one thing, right? Try to relate the formula with the words, right? Then you can remember that formula forever. Like now in this case we have what is called as the EMF and current, right? So in inductor, what leads? EMF leads or current, right? Most of the students will have confusion in this. In capacitor, what leads? Current or EMF? By pi by 2 that we know, right? But what leads? Current leads or the EMF leads, right? For that, one famous book is there, and that book name is Eli the Ice, right? If you remember this statement, you can actually remember everything related to inductor, everything related to capacitor. Now see here, in inductor, this L represents inductor. Eli the ice, right? It is related to iceberg and all, right? So over here, it is inductor. In inductor, L represents what? Inductor. In inductor, this E represents EMF. EMF leads the current by pi by 2. Okay, so this I represents current. So in inductor, EMF leads the current by pi by 2. So if you wanted to draw the diagram, this is the current supposed to be. Then you have to draw for inductor, obviously. For inductor, this is, if this is the current, then EMF leads the current by what is called as the pi by 2, by what is called as the pi by 2. So this is the diagram for inductor, and for capacitor, current leads the inductor by current leads the EMF. So this I is current and this E is EMF. So current leads the EMF by pi by 2. So over here, if you just draw the EMF over here, then current leads this by pi by 2. You can draw like this, or else you can draw I over here and E downside, isn't it? That means current leads the EMF by pi by 2. So I hope this is clear, right? So you just have to remember one statement, Eli the ice. Now the charging of capacitor, discharging of capacitor, right? Whatever formulas are there, that how to remember, I'll tell. So the next one we have, next 3 to 4 formula are related to this one only, and that is, firstly, if we have a pendulum, right? Pendulum, and if this pendulum oscillates, and if we consider the damped oscillation, right? If we consider the damped oscillation, that means air resistance is there. Then whatever amplitude decrement is there, that decrement amplitude, if you wanted to write, that is equal to, right, amplitude at any time t. This is the amplitude at any time t. Amplitude of the pendulum at any time t, right? At any time t is equal to the maximum amplitude times e to the power minus k into t, right? Maximum amplitude, whatever the initial maximum amplitude is there, right, times the e to the power minus k into t, indicates this this amplitude will decrease automatically as time passes. That is what the decreasing amplitude, that is damped amplitude, indicates, right? Damped oscillation indicates, right? Likewise, in modern physics, one more formula is there, and that is for number of counts remaining, isn't it? Number of counts remaining. So this video is totally for those who did study, right, for NEET, for JEE, or for any competitive examination. This is not at all for beginner, right? So I'll suggest for beginners, you just go through the chapter, each and every concept you have to study by your own, and after completing everything, if you wanted to revise, how to revise, that is what I'm saying in this video. right? So now see, amplitude we have seen. Now we want number of counts remaining, right? In a radioactive material, alpha decay is there, beta decay is there, gamma decay is there, right? So the particles will decay, right? Now what is the number of counts remaining? If you wanted to calculate, then that is the given count, whatever the initial maximum count is there, that into e to the power minus k into t, right? That means as time passes, that count decreases automatically, right? E to the power minus k into t means what? The number of count decreases automatically. Okay. Now this k is equal to 1 by tau, that is the average lifetime we have. Sure. Next one, fourth one. See here, I am taking all the formulas related to the e to the power minus k into t, e to the power minus t by k, whatever it is, right? So over here I am taking everything in that term only. Okay. So I hope this is clear. Now fourth formula, right? Discharging of capacitor through the resistance, right? So discharging of capacitor through the resistance will have the formula, and that is V is equal to V naught e to the power minus t by k. Now capacitor discharges in the form of potential and inductor discharges in the form of current. Why? Because capacitor stores the energy in the form of electric field, and inductor stores the energy in the form of magnetic field. And that is the reason for capacitor, energy we have is half CV squared, but for inductor, energy we have is half Li squared, isn't it? So over here, energy across the capacitor, if you want, you can remember like this, 1 by 2 CV squared. Why? Because energy stored by capacitor is in the form of electric field, and electric field related to potential, and the energy stored by the inductor is in the form of current. So E is equal to 1 by 2 Li squared. So I is related to magnetic field. So I hope this is clear, right? So discharging of capacitor and discharging of inductor. Discharging of capacitor is with respect to voltage. So it will have voltage across the capacitor will decrease. It is in the form of V naught e to the power minus t by k, right? If you wanted to draw the graph, it is V versus t, and it will be initially at t is equal to 0, it will have the maximum voltage, and as time passes, its voltage will decrease. Okay. And likewise over here, if you take the current and the time, at time t is equal to 0, it will have the maximum current, and as time passes, the current will be then 0. Current will be then 0. So I hope this is clear. Right. So as you can see, voltage V is equal to V naught e to the power minus t by k. Amplitude over here, A naught e to the power minus kt. The number of count remaining, N is equal to N naught e to the power minus kt. Discharging of capacitor, discharging of inductor, all are having the same formula. Like the relation will be the same, right? Some constant A is equal to, that is the function of time, is equal to A naught e to the power minus kt for the amplitude decrement. Then we have second formula for number of counts remaining, N naught e to the power minus kt. Same thing. Third one, we have capacitor, right? Discharging of capacitor, V is equal to V naught e to the power minus k by t. Over here, what is k? R into C, right? T by k it is actually, and RC is called as the time constant. So it is actually represented by tau only, but I wrote over here k. Nothing will happen, right? Likewise over here, time constant is L by R. Okay. Now charging of capacitor, charging of inductor, as you can see, it is E naught e to the power E naught 1 minus e to the power minus t by k. If you wanted to draw the diagram, it is E versus t. Initially, if you just take the t is equal to 0, it will be 0, and as time passes, it will charge to the maximum value. And likewise, I versus t, if you, as time passes, it will charge to the maximum value. So this two formulas are of same thing. Only difference over here is that capacitor will charge in the form of voltage and the inductor will charge in the form of current. This you need to remember. And as you can see, for inductor everywhere is current, and for capacitor everywhere is voltage. That you need to remember. Now, eighth formula. This I took from a rolling motion, that is rotational dynamics. Voltage we have velocity, acceleration, time, right? So velocity, acceleration, time. Velocity we have generally we take as the root of 2gh, right? In terms of g and h. Instead of g, you have to replace this g with g by 1 plus k square by r squared. What is k? It is the radius of what is called as gyration, right? Radius of gyration, and that value is root of I by m. So that is mk square and all. Okay. So the velocity we have is root of 2 instead of g by 1 plus k square by r square. G sine theta we have for inclined plane, isn't it? This is g. If you consider, then it is g sine theta. This is the g sine theta we have. Then instead of g, you have to put g divided by 1 plus k square by r square. Instead of g, we have to put g divided by 1 plus k square by r square. Likewise, these three formulas you can remember. Only thing is over here, for time formula, we have 1 by sine theta. Rest all formulas are same. Likewise, you can make the formulas which are just similar, right? And you can actually make one notebook, right? Make one notebook. In that, just write down the formulas which are just similar one, like time of flight we have, then the range we have for projectile, right? Then in EM waves we have the spectrum, frequency in which direction it will increase, wavelength in which direction it will increase. So if you want the more formulas, do comment in the comment section, so that I will provide more formulas with amazing trick. Thank you so much.